So, okay, let me again draw just some plane. Okay. All right. Okay, so there's a way for us to define this plane with a scalar equation, meaning without vectors, just as an x, y, z. Now here's how you do it. First of all, the way we defined it so far was this. We got two vectors, and we got a point there. Right? We got a point there. So that point P0, so right now it was this. P0 plus S direction 1 plus T direction 2. Now think of it this way. Okay, there is a point. What I'm going to do now is get a vector that's perpendicular to both of these vectors that I have. We call this the normal vector. Okay. So imagine like you have a plane. Imagine you had a plunger. Oink, you plunged it, right? I don't know if that looks like a plunger. Okay, you're stuck on it. And then if you move the plunger around, wouldn't the plane move around with you? It would, right? That's what this vector kind of does. Okay. So can we find this n with this given information? Sure we can. It's the cross product of d1 and d2. Okay, so we're going to use this idea to come up with an equation of plane. Let me actually do this example with a number rather than labeling everything with algebra. I think it's going to get more complicated. I already have a video recorded in that way, and that's like a general proof why we can turn this always into scalar. Okay, so let's just do one with a number. Okay, so let's first find the normal of this. To do that, I'm going to list it like this. Okay, so cross that out. 10 minus 1, cross that out. Minus 1 plus 4, cross that out. 2 minus 5. So the normal vector is 9, 3, negative 3. So we can actually make that nicer. Divide everything by 3. 3, 1, negative 1. So think of it as this. We got my normal vector. I know this vector, it's a vector, so it can move around. So what we need to do is fix this vector on a particular point that's on the plane. Now, here's how we define the plane. If the point is on the plane, okay, or all the points on the plane, so let's call that point, because it's all the points on the plane, I'm gonna let it be a variable, x, y, z. If this point is on the plane, if you get this vector right here, see this vector? From where the normal meets, and if this happens to be on the plane, what should be the result with the normal and this vector down here when you do a dot product? 0, right? Okay, so this point right here, I'm going to use this one that's given. Okay, so this vector here will be x minus 1, y minus 2, and z minus 1. Dot product with the normal should be 0, right? If x, y, z are points on the plane. Look, let's do the dot product. 3x minus 1, y minus 2, minus z minus 1. Expand. Let's put the variables first. Minus 5, minus 4. This is a scalar equation. Okay, look at the coefficients. The coefficient is 3, 1, negative 1, right? 3, 1, negative 1. Look. It corresponds to the normal coordinates. This equation defines all the points on this plane.